Just start talking.
All right, so that was good job with the fire drill. Way to walk straight back. Okay, now that we're back to class. It happens a lot when the weather's nice. Okay, so we started again on the inside. Was a natural number. That is the smallest subset with the fewest numbers. 1, 2, 3, 4. Okay. Whole number is the one above it. The only difference between a whole number and a natural is that whole numbers include the number 0. Everything else is the same. The next subset, I'm going to add a larger box, is an integer. Like we learned in chapter 1, an integer is adding in the negatives. -3, -6, -11. And still includes 0, 1, 2, 3, and 4. The last subset, the largest box, is referred to as a rational number. What number are we missing? What would I need this last set for? Okay, do you notice how we don't have any fractions or decimals on the board? A rational number represents, adds in that fraction or a decimal. And they can still be negative, -0.3, that's okay. Rational is good. The last set here, I'm going to tack right onto the edge. It's separate, kind of in its own space here, is an irrational number. An irrational number. These are numbers that don't end. You're arguing and arguing with a person. That person is arguing, and they are irrational. They don't make any sense. They don't make any sense. They're all over the place, just like an irrational number. It goes on and on and on, and there's no pattern, and it's just blah, blah, blah. Irrational. Just like people. All of these numbers are called real numbers. All of the numbers you have ever learned in a math class ever, up until today, are called real numbers. Okay? So today I'm going to show you something new. So on your paper, if you're at the bottom of the page, turn the page over. Start a new space. And I want you to write down imaginary. An imaginary number. This is new. An imaginary number is when you have a negative under the radical sign. What? Doesn't make any sense. Okay, I'll explain it to you. It's going to be okay. Don't worry. Okay? An imaginary number is any number where there's a negative under the radical sign. For example, do you remember when we took the square root of 9, very first problem? What if I put a negative on the inside? Okay. This turns into 3i. I stands for the negative under the radical. Imaginary. Square root of -9 equals 3i. Let's try another one. What would be the square root of -25? I bet you can guess it. What's the square root of 25? 5. So square root of -25 is 5i. Okay, that's it. Nothing crazy. Please don't call them fake numbers. They're not fake. They're imaginary. My imaginary friends aren't fake. I believe in them. They exist. They're real. Okay, let's try just a couple more. Square root of -48. Let's go back to that original problem. What if I have a number inside and outside? This becomes 4i radical 3. 4i radical 3. Always. Run out of space. Okay? Always. It will look like this, the top. This is important. number, I, and the radical. Always in that order. Any questions? Yeah, it's not terrible. Where does this fit? Why did I make you write this chart? This is ridiculous. You wrote all this information down to put a negative sign in a root. What's the point? Go back to your chart. You don't need a lot of space. Go back to your chart. Imaginary numbers are over here by themselves. Kind of like your imaginary friends. They're not really a part of the real world. They're not really a part of everything else. 3i plus or minus 2 pi I. What? Pi? Can't talk about that. 2 pi I. We'll let it go. These are imaginary numbers. These are real. They are separate. Only one more definition. We're almost done with the definitions. Last definition. A complex number is the combination of real and imaginary. A complex number is the combination of real and imaginary. It has a special formula, and it looks like this. A plus BI. Memorize it. Test question. I love to ask you to write things out on test questions. If you look at your chart, take a pretty highlighter out. Nice red pen. This entire board, everything that we've done here, these are considered complex numbers. Okay? These are all considered complex numbers. Questions?
Okay.
Sorry. I'm not used to having such a small board.
All right.